Good morning, students. I hope I am audible to all of you. Please respond in the chat box whether you are audible or not. Okay. So those who are already present, please give your attendance in the chat box if you have not given it yet. Those who are already present, please give your attendance in the chat box if you have not given it yet. And a few students are not yet named as their enrollment number. So please rename yourself with your enrollment number. Please rename yourself with your enrollment number if you are not named with your enrollment. Okay, so we will just begin in 2-3 minutes. Please finish giving your attendance till then. Please give the attendance only once. Enrollment number, full name, stream, section, roll number. Please give the attendance only once. Those who are present, finish giving your attendance. We will just start in 2 minutes. Okay, so let us start. Now, first thing is due to some reasons I had to cancel the class of Sunday. Only my class is cancelled. I am not sure about the others. So if not any notice being given, then you can assume that the other classes will go on fine. Okay, in time. Now, as today is our Bengali New Year first day, so my good wishes to all of you on the auspicious occasion of our New Year, Bengali New Year. So, Shubho Novobarsha to everyone out there. My best wishes to all of you. I hope you prepare well and perform good in your upcoming placements and your classes all. So, with that note, we will start our class today. We will be now, one thing from this week's class, yes, Shubho Navavarsha to all of you. My good wishes to all of you on the first day of the Bengali New Year. Now, as per your schedule, from this week onwards, we are supposed to have our software engineering class. Now, one thing that our DBMS is not yet over. Okay. So what we will do is we will be in a 3 hour of class. We will be doing both DBMS and software engineering parallelly till our DBMS is done totally. Okay. So I hope you understand. One module of DBMS is left, that is the transactions, and few things in SQL is also left, like few examples. Now that we can discuss at some end, like just before your semester exam, one class we can give for that. But simultaneously from this week, we will be dividing the class into two halves. We will be doing the software engineering as well as the DBMS, as the DBMS is not yet over. Fine. Now, for CSE students, software engineering is also going on parallelly in your theory classes. So, but for non-CSE students, this subject is totally new. So there may be few students from non-CSE background who are present in the class, but for them, this subject is totally new. So, and in this stipulated time, covering the total subject is not possible. Okay. So what we will do is, we will take up some topics that are likely to be asked in your viva or interview or whatever, and we will discuss only those. So please understand this. For CSE students, more or less it is mandate to write software engineering in your CV, because firstly it is an easy subject, and secondly the knowledge is practical oriented, so it will be expected from you. Now for CSE we are doing it in the class, right? Parallelly we will do it here also, discussing some problems, questions, etc. Now for non-CSE students, this subject is totally new. Even if there are 10, 20 non-CSE students, for them also it is totally new. So we have to deal with it in such a way that it becomes a bit of easy, right? So what we will do is, only the areas from which you are likely to get questions, we will discuss that, right? And for CSE students also, the total syllabus is not yet over, right? So we will start from very basics, right? Now, what I suggest is, when we discuss, for non-CSE students especially, when we discuss, please note down the points so that you can study later, right? Because software engineering will not be covered in your curriculum, right? So you have, whatever you acquire knowledge, you have to do it from here. Fine. And for CSE students, it is mandate, it is getting done in your class as well. So there is no question that you are skipping this subject for your interviews, right? So today what we will do, today we will be dividing the total time into two halves. First half, we will be doing few of the software engineering things. And in the second half, we will be doing the DBMS transactions. Okay, so till DBMS is totally done, we will be continuing our classes accordingly. Okay, so I hope it is clear to everyone. Now, the first thing that is coming into our mind is what we need to study from software engineering for our interview purposes, right? So this is for all, not only CSE, for all, right? So if we take the total thing as a subject, then it has got several modules, but I'm not discussing on the modules here. What we have to study is, first thing, you have to study the SDLC, Software Development Life Cycle. SDLC, Software Development Life Cycle. So this you have to study. There are several models, so this you have to study. Second one is all about project management. All about project management. This you have to study. Third is, you have to study about the diagrams. You have to study about the diagrams, UMLs. Unified Modeling Language. Unified Modeling Language. UMLs you have to study. Now, under UML, you will have different type of diagrams. So those you have to study. Means you have to identify which one is what. Next, very important, you have to study the testing. Right. You have to study the testing. And last one is all about the quality control and maintenance. right? Sorry. So these things you have to study. Fine. So important is SDLC, project management and testing. UMLs and quality control you have to study, means in a nutshell you have to study, right? So today let us understand that this subject is of like you can say this is a very easy and a practical oriented subject, right? But the part where you have problems will be the project management, right? The portion where you will have problem is the project management. So what we have to do is we will be identifying the areas and we will be finding out that what can be asked in project management and what we have to, like how we have to manage our answers, right? So first thing first is we will be discussing a problem in project management, and for CSE students it must be a bit of easy if you have attended my class. If not, I will be telling here just the basic shortcut that if it is given as a problem, how to solve it, right? So totally defining everything on a particular problem I am not telling, like I'm not going into very much depth, because this is a mixed batch. This is not only CSS, this is a mixed batch. So I will just tell the problem statement and I will tell how to solve, right? So it will be, I hope it is easier for you to grasp. Now for non-CSE students, again I say, if you find difficult is software engineering, it is not difficult, but if you find, you can take the PPTs either from me or from any of your CSE mates. Right, the PPTs are all available, but here in this stipulated time using PPT, if I start to teach, it takes time, right? So CSE students know that it will take much time. So I am not going into PPTs, but if you need PPTs as your reference, you can either take it from me or you can take it from your CSE friends, right? So what we will do today is, first we will give the idea that what is software engineering. Now see, we are studying different things, like we are studying coding, we are studying database management system, we are studying machine learning, we are studying many things. We are studying like networking, security, these things. Now, when we go to apply all this in a company, what is the approach of working? This is what your software engineering is all about. So when you go to any company, what working model do you follow? What is the approach of working in a particular environment? There you will not be a student anymore. So how to behave, or what type of what type of culture you have to follow, these things are being discussed in software engineering. Now along with that, when you are talking about the software, that means you are talking about a product, right? Software and a product are same thing for a company. They get the order from a client, they work on that and they deliver. This is the approach. Now, what we will discuss today is, if suppose a particular set of tasks is given to you and you are required to identify what is your critical path. So we call it as a CPM problem, critical path method problem. So what we do is, a set of tasks is given to you. You will be arranging them in a graph-like structure. That graph-like structure, we call that as the activity network. CSE students must know it because right away we have done. For non-CSE students, please note down the terms, right? So activity network can be represented in two ways: activity on the node and activity on the edge. I'm not going into details that how activity on the node will be represented, how activity on the edge will be described. I am just right away taking an example and solving it to the point, teaching whatever is required. I'm doing that, right? You may have some confusions at some point. Please ask. Okay. So what we are doing, a set of tasks, like suppose T1 to T15 is given to you, you will be arranging that in an activity network like a graph, and you will be identifying that in that graph, you all of you have studied graph, like in data structure mathematics you have studied. So in that graph, if I have multiple paths, please understand, in a graph, if I have multiple paths, right? Suppose this is my starting node and suppose this is my ending node. So from node, I am going here in another node. These are nodes. So from here, I am dividing it into two more nodes. From here, I am dividing into three nodes. From here, I am going to one node. Now this node and this node is going here. This node is going here. This node is again suppose divided into two more nodes. And everyone is going to an end, right? So suppose this is a type of graph. This is node specific graph, right? So on the nodes, these are my nodes. So on the nodes, we will be writing name of the task or name of the activity, right? So this will be named as the AON, activity on the node, right? Now suppose this, on this particular type of graph, on the edges, like this line, these are my connecting edges. On the edges, if I write the task, the name of the task, then we call it as the activity on the edge, right? Mostly we are concerned with activity on the node. Activity on the edge, more or less, we do not consider, but activity on the node is the one where we work, right? Now, a set of tasks will be given to you, which you have to arrange according to an AON diagram. After you arrange them, then you have to calculate some time parameters. Some time parameters. What are the time parameters? Earliest start. Earliest finish. What are these? I am telling you when I start solving a problem, I will tell you in runtime. Okay, just note down the names. Latest start, latest finish, slack time, and this is my MT, minimum time, right? So these are my timing parameters which I have to calculate, right? Now why you have to calculate? Suppose there are 10 nodes. Suppose there are 10 nodes on my activity network. For each node, you have to calculate all these 5. For each node, you have to calculate all these 5 parameters. And for the network, for the overall network, you have to calculate the MT. Now, after doing this, the nodes whose slack time is equals to 0. The nodes whose slack time is equals to 0, if you join them, you will get your critical path. Suppose there are 10 nodes present in your activity network. For each node, you have to calculate these 5 time parameters: ES, EF, LS, LF, and ST. After that, you overall for a network, you have to calculate the MT, the minimum time, only once. Overall for a network, not individual for the nodes. After you calculate all this, you finish a table, a tabular format. Find out for which nodes my ST, slack time parameter, is 0. Find out for which nodes my slack time parameter is 0. Those nodes, if you join, you will find your critical path. Understood? So a set of tasks will be given. Suppose 10 tasks, T1 to T10. For each task, you have to calculate 5 individual parameters. So suppose you are calculating total 50 parameters if 10 tasks are given. What is the formula to calculate? Everything I will explain when I do it runtime. So after you calculate all the 5 parameters, you have to calculate the minimum time. Minimum time is only once calculated for an overall network. Okay. After you finish all the calculation, from the table you will find that for some of the nodes, the slack time is equals to 0. ST is equals to 0. If you connect those STs, you will get your critical path. What is a critical path? Now come to the point. Up to now you are telling critical path, critical path. So what is a critical path? In a particular network, if there are multiple paths existing from start to finish, which path is taking the maximum time? So that if I miss any task or take delay in any task on that particular maximum time path, there will be a schedule slippage. Very, very important term. So if there are multiple paths from start to end, right? Multiple paths from start to end, the path which is taking the maximum time to finish, that path is named as the critical path, because if any of the tasks on that particular maximum time taking path is being delayed, that means it is consuming more time. Delay means what? It is consuming more time. Then there will be a problem in the delivery. Delivery of the product has got some timelines, right? So if there is a problem in the maximum time consuming path, then we will face a schedule slippage. What is schedule slippage? The delay in product delivery. Due to any task, there can be multiple reasons of schedule slippage. So if there is a delay in any of the tasks, then there can be a delay in the total product delivery. So we call that as the schedule slippage. We call that as the schedule slippage. Okay. So what is critical path? If there are multiple paths, if there is only one path from start to finish, there is no problem. That path is your critical path. That path is your every path, right? If you have multiple paths, then the path which is taking the maximum time to finish, if there is a problem in any of the node, any of the activities on that maximum time taking path, there will be a problem in the product delivery. The timeline will be delayed. So this particular phenomena is named as the schedule slippage. You are not able to deliver your product within time, right? So critical path has to be calculated in order to avoid the schedule slippage. If I identify the maximum time taking path, then I can understand that if I follow this path, I have to be careful because this one is taking most time to finish. So even if I am following this path, I have to match all the deadlines, right? So this is schedule slippage, right? So up to now, what we have studied that some activities are given. We will arrange that activities on an activity network. Probably we will follow the activity on the node. The name of the task are given on each of the node, right? After we arrange that, we will be creating the MT. We will be calculating the MT, minimum time parameter. Then we can calculate for each node all the 5 timing parameters that are given in front of you. Then from the table that you have created with all the timelines, we will find out for which task the slack time is equals to 0. For which task the slack time is equals to 0. If I connect all the nodes whose slack time is equals to 0, then we will say that those nodes are creating my critical path. Why it is named as critical path? Because it is consuming the most time, and if you fail to meet any of the deadlines of the nodes on that path, it means you can have a delay in the product delivery on a whole, and you will face the schedule slippage, right? So this is your idea more or less on an activity network. More than this, you do not require for your interview. This is what is required. Now, let us do a problem. Let us do a problem so that you can understand how actually the critical path goes, right? Let us do a problem. First, let us find out how many activities and tasks everything is given. So suppose for a particular product, we are identifying the activity number, the activity name, the duration of the activity. So the duration can be in weeks, in days, in months. That will be specified in your question. Suppose in weeks. And the last parameter that is required to draw the graph is the immediate predecessor. The immediate predecessor. So these 4 parameters are supposed to be given in your question or problem, right? Okay, so there is a question, ma'am. We will be selecting only that part where the delay is 0. Delay is 0. This you cannot calculate. We will be selecting that part where the slack time is 0. Slack time is what? What is the latest time you are starting, the latest finish time, and your earliest finish time. There will not be any delay in that, right? So delay you cannot calculate directly. We will be considering the maximum time consuming path. Okay, so if there is a problem, yes, when the slack time is equals to 0, right? So suppose we have activities, suppose 1, 2, 3, 4, 5, 6, 7, 8. There are others also. So I'm just writing. Suppose the first one is requirement, name of the activity. You don't have to understand the name right now. CSC students will understand it a bit, but others may have a bit of problem. So just understand this is the name of your node. Okay, on a graph, this is your name of the node. So first one is REQGS. Duration is suppose 4 weeks. There is no immediate predecessor. Second one is analyze operations. Duration is suppose 4. Suppose this is also do not have anything as the predecessor. Define subsystems. Suppose the predecessor is node 1. Under immediate predecessor, the numbers that I'm writing are the numbers of your activity number. Okay. So activity number 3 is having its immediate predecessor as activity number 1. Okay. Develop the database. Right. Next one, decision analysis. Decision analysis. Identify constraints. Right. Number 7, 7, 8, 9 are building of modules, right? So developing or building module 1, building module 2, building module 3, right? Suppose it is taking 8, 12, and 18. So this is a standard problem that I have taken from your textbook only. But I will solve it in front of you so that you can understand how to do it. Okay. So using the subsystems, database, and your constraints, we are developing the modules. Right? Next one, number 10 is preparing the report, or you can say documentation, whatever. It is consuming 10 weeks and predecessor is 6 based on the constraints. Next one is the testing. Testing will be on modules. So 8, 9, and 10 task number. It will be on modules. Testing will be done on modules. So 7, 8, 9. And the last task is the deployment, or you can say the implementation. Right? Based on your reporting and your testing, your implementation will be done. So this is your problem statement given, right? Problem statement given. So what is there in the problem statement? The activity numbers, so T1, T2 up to T12, the name of the activity, the decision, the durations that are being taken, and the immediate predecessor to draw the network. So this is your total table given, right? So it can be given in the form of a table or it can be given in a problem statement. Immediate predecessor means what is a, see, there are two terms in a graph, predecessor and successor, right? So I have shown you this total table in one frame. So I hope you have taken a screenshot, or if you are writing, very good, or else you must take a screenshot at least. Okay, so these activity numbers, we represent them using T. Okay, so T1 to T12, right? Okay, so what is a predecessor and what is a successor? Suppose if you consider this node that I have made a square, the predecessors are this one, this one, this one, and this one. So the ones which are previous are their predecessor. Who is the successor? The one that is following it, means after, is the successor. So predecessor means previous node, successor means the following node. So to draw a graph, generally we require the predecessors. Okay, if you give predecessor, successor both, then also you can draw, no problem. But predecessors are the minimum requirement. What is a immediate predecessor? Immediate predecessor means to complete this task, I require this task also to be completed, this task also to be completed. These two are getting joined here, right? So this one and this one are your predecessor, immediate predecessor. What is immediate predecessor? If a node is given, suppose this is one node. Previously, I had two more nodes. This is coming from this one, this is coming from this one, and suppose this one. And this and these are joining here. So these ones, predecessor, are everyone present in the previous graph. But immediate predecessor means this one and this one, because once these two are completed, then only this can start. Right? Once you finish developing your modules, then only you can go for testing. Once you finish testing, then only you can implement. Right? I hope you are understanding. So what is immediate predecessor? Who is just previously happened. That is the immediate predecessor. Okay. Now, based on this table, we will be constructing the AON. Right? So I will give the names on the network as T1, T2 to T12. Okay, big names I am not writing. If you want, you can also write the big names. Okay. So now let us begin. Okay. So first one is REQGS. T1, right? Now see, the T1 and T2, these two are not having any predecessor. That means these two are your starting point of the graph. Please understand, please follow my words. T1 and T2, activity 1 and 2, requirement analysis, REQGS, and analyze the operations. These two are not having any predecessor. This is blank. That means these are the starting point of your graph. These are the starting point of your graph, right? So before this, nothing has happened. Okay. Now, next one. T3 is having T1 as its predecessor. And T4 is also having T1 as its predecessor, right? That means from T1, I will be having 2 points. One is my T3 and one is my T4. I'm not writing the full names because the space is small, right? If you have it in your exams, you will write full names. If you are going for your interviews or viva, full thing is not required, just the task names will work. So from your T1, you are having 2 other tasks, T3 and T4. Next, T5 is having the predecessor as T2, right? So from T2, I can write T5. From T5, I will have T6. From T5, I have T6. See, T6 is having T5 as its predecessor, right? Next, important, 7, 8, and 9, everyone is having T3, T4, and T6 as their predecessor. 7, 8, and 9, individually, everyone is dependent upon T3, T4, and T6. So how we will draw? Take T3, take T4, take T6. This is one point. From this point, you have to draw T7, T8, T9. T7, T8, T9, right? So T7, T8, and T9, you can see the box here, the table. T7, T8, and T9, everyone is depending upon T3, T4, and T6. So how to do that? Connect T3, T4, and T6, connect them. From there, 3 other nodes are getting generated. So I have drawn it like this. Okay. Next, T up to T9 it is done. Next, T10. T10 is having the predecessor as T6. Only T6. So from T6, there is another one, that is T10. Right? Next one, T11 is having predecessor 7, 8, and 9. So 1, 7, 8, and 9 are what? Your building of modules. So once you are done with building of modules, you are able to test them. So once 7, 8, and 9 nodes are finished, my testing node can start. So from the 7, 8, and 9, you can draw the T11, right? And from T11 to T12, you have your T11 and T10, you are having your T12. You are having your T12. So that can be drawn like this, right? So this is your activity network. Till now, it is not done. What else you have to specify? The duration of each node. The duration of each node has to be represented on the node along with the activity name or the task number. Okay. So T1 is having the activity time as 4. T2 is having the duration as 4. T3 is having the duration as 2. T4 is having the duration as 4. T5 is having the duration as 3. T6 is having the duration as 2. T7 is having the duration as 8. T8 is having the duration as 12. And T9 is having the duration as 18. T10 is having the duration as 10. Okay. T11 is having the duration of 8. T12 is having the duration of 2. So all the durations I have written here within the box. Right, within the box I have written all the durations. So this was having 12. Okay, and this one is having 8. So just let me draw it a bit clearly so that those who are doing it for the first time, it is easier for you to do. Okay, so the durations specified in the box table, the durations specified in the table, those durations are mentioned within the node. Those durations are mentioned within the node, on the node or within the node, whatever you tell. So this is your AON diagram, right? In the nodes, you can write the task numbers if it is given in the question, or else you can write the total name of the activity. Okay, so this is what your activity diagram looks like, right? Now next, what I have to do, I will be identifying from the start. This is my, these two are my start points, and this T12 is my end point. So how to reach from the start to the end, I will be identifying all the paths, all possible paths. Possible paths from start to end. Start means T1 or T2 and end means T12. Okay. Okay, so I will be specifying the path. So path number 1, path number 2, path number 3, path number 4, path number 5. Let us see how many paths are there. So if I start from T1, T1, T3, T7, T11, T12, right? This is one path. Take a screenshot of this diagram or click a picture of the diagram so that when I write the paths, you can easily identify. Up to the drawing of the AON diagram, is there any problem? Especially I am asking to non-CSE students, those who are present. Up to drawing the AON diagram, is there any problem? Yes or no, please respond. I am asking this to everyone, especially to the non-CSE students who are present. Have you understood from the diagram how to draw the graph? More or less all of you have studied graph theory or mathematical graph, anything, or data structure graphs, right? Okay, so next we are moving towards identifying the paths. Okay, so take a screenshot of the diagram. Okay, so first path is, if I start from T1 to T3 to T7 to T11 to T12, right? So what is the path? Just drawing it roughly. If I follow this one, if I follow this one, then this is one path, right? This is one path from start to finish. This is one path. Fine. Next, if I follow this, sorry, if I go by this, but I go via T2, T8. If I go via T7, I have gone via T7. Now I am going via T8. Next, I will go via T9, right? I can go via any of the three. Understand what I mean to say? If I follow T3, after T3, T7, T8, T9, any one path can be followed. So that is what I am writing. T3, T8, or now here some students may have a question that, ma'am, T11 cannot be done when T7, T8 and T9 all are done, right? So how can you take only one node? See here, when you are trying to identify paths, you have to only see that from start to end, are there connecting points or not? You don't have to apply your mind that which task is going fast or second, right? Predecessor, successor, using that I have drawn the graph. After that, I am trying to identify that if I follow a certain path, now one path cannot cover all nodes. Understand, T12 cannot be done once all the previous node, T1 to T11, everyone is done. But if I consider that, I cannot take out individual paths. So when I am talking about individual paths, all the previous predecessors will not be done. Only one by one paths I am identifying. So see here, after T1, if I go via T3, T3 can be done via T7, T8, T9, or, right? Then T11, then T12. Fine. Similarly, from T1, if I go via T4, then also same thing. T7, then T11, T12, right? So if now I will follow that from T1, I will now follow T4, right? T1, then T4, then T7, T11, T12. T1, then T4, then T8, T11, T12. T1, then T4, then T9, T11, T12. Right? Up to this is fine. Now, can I start from T1 and follow any other path other than these six? Tell me. I have started from T1. I have taken all paths possible via T3, all the three paths. I have taken T1 and I have gone via T4 and all the three possible paths I have taken. So 6 paths are done. Now, other than these 6 paths, if I start from T1, no other paths are possible. So T1 is done. Now I will start with T2, right? Now T2, then T5. After T2, I have to go to T5. After T5, I have to go to T6. No other path is possible, right? So T2, T5, T6. Now after T6, again, I will follow any of the 3 paths, T7, T8 or T9, right? To reach to the end. So T2, T5, T6 is fixed. After T6, I have to follow either T7 or T8 or T9. Then T11, T12. Okay, these are the 3 paths. Let me write them. So I will start from T2. So number 7, T2, T5, T6, T7, T11, T12. T2, T5, T6, T8, T11, T12. T2, T5, T6, T9, T11, T12, right? So upper part, if I start from T2, if I go via the upper part from T6, that is done. Now, if I start from T2, then T5, T6, T10 is another path which is going directly to T12. T6 is also leading to T10. T6 is also leading to T10 and T10 is leading to T12. So this is another path that I can follow, right? So I will write that T2, T5, T6, T10 and T12. This is last path. So I have recognized 10 paths from start to the end. From start to the end, possible paths are 10 paths are identified, right? 10 paths are identified. Now what you have to do next? You have to calculate the MT. MT. What is MT? For individual paths that you have taken, you have to calculate which path is taking how much duration. Which path is taken how much duration, right? How to do that? Nodes you have written on each path. Every node has got a duration. You will just add all the duration and you will find out that what time that particular path is taking. What time that particular path is taking. So for every path, you have got some of the tasks, some of the nodes. Every node has got some duration given in the table or in the diagram. So you will just add them to find out the duration if I follow that path. So path 1, duration of T1 is 4. Duration of T3, 2. Duration of T7, 8. Duration of T11, 8. Duration of T12 is 2. That means 6, 8, 3, 8 is 24. So each path, the tasks that are being covered in that path, you have to calculate the duration if I follow that path. So how to do that? Take the duration of each task, add them to find out the duration consumed by that path. Okay. Likewise, you have to do it for all 10 paths. So 4 plus 2 plus 12 plus 8 plus 2, right? Okay. 4 plus 2 plus 18 plus 8 plus 2. Okay. Next one. 4 plus 4. T4 is 4, yes. Then 8 plus 8 plus 2. That is 26. Next, 4 plus 4 plus 12, 8 plus 2. 4 plus 4 plus 18 plus 8 plus 2. sorry, 36. Next, this one, where I'm starting for T2, right? So I'm starting with T2. What is the duration of T2? 4. So 4 plus T5 is 3 plus T6 is 2. T6 is 2, yes. Plus T7 is 8 plus T11 is 8 plus 2. 27, okay? Next one. What is the duration of path number 8? Calculate and tell me. What is the duration of path number 8? Calculate and tell me in the chat box. What is the duration of path number 8? Calculate and tell me. Path number 8. Path 8 is 31. Good. Path 8 is 31. So there is nothing difficult to understand. 31, done. Path 9. Tell me for path 9. Tell me for path 9. 37. Yes, 37. And last path 10 is 21. Nice. So path 10 is not 28. Path 10 is 21. One student is saying path 8 is 28. It is not 28. It should be 21. Right? Now, all paths duration I have taken. So, which one is taking the maximum duration? Path T9 with a duration of 37 weeks. With a duration of 37 weeks. Okay? So, my critical path must be aligned to T9. My critical path must be aligned to T9. Okay. So which path is taking the maximum time? Which path is taking the maximum time? T9. So what is T9? T2, T5, T6, T9, T11, T12. Right? So this is not T9, sorry. This is path number 9. Path 9. Okay, path 9. Fine. Now we will start discussing on the parameters. I have to find out next. I have to find out what? Slack time of path 9. All the nodes of path 9 should have a slack time as 0. All the nodes of path 9 should have the slack time as 0. Right? So for that, the first calculation is MT. Now see, there is a bit of confusion. MT is the full form of MT given by your books or documents, whatever, is minimum time. But the definition of MT, how to calculate MT? The maximum path, the maximum duration, not the maximum path, the maximum duration attained by any path of your network is the MT parameter. So here your maximum path is having 37. So your MT becomes 37. So why I have calculated the duration of all possible paths? To find out the MT, nothing else. Okay. So what is MT? MT is the maximum time. MT is the maximum time. Okay. Now, what is the value of MT for this network? MT will be calculated only once. MT's value is the maximum paths value. Okay, MT's value is the maximum paths duration or maximum paths value. Okay. Okay, I'm just coming in 1 minute. I'm just coming in 1 minute. Okay, so yes, the term is minimum time, but very surprisingly, the calculation is done for maximum time. Okay, so we have to calculate the maximum time given for your network. The paths you have to calculate, and for any one of the path, it has to be taking the maximum time. Okay, so that maximum time is allocated under MT. Now, next, we will be making a table where on the left hand side, we will be writing the name of the task. Right? And on the matrix, we will be writing here the parameters. Earliest start, sorry. Earliest finish, latest start, latest finish, and slack time. Okay. Now, we have to start the calculation. Now, first thing, what is earliest start? How to calculate earliest start? For any node, if there are multiple previous paths, for any node, if there are multiple previous paths connecting to that node, then the maximum duration of the predecessor path is your earliest start. If any node has got only one previous path, to join, then that path's duration is the ES. But if any node has got multiple previous paths coming and meeting to that node, then the maximum duration taken by the predecessor path. If there are three paths, which one is taking the maximum time is the earliest start. Okay, is the earliest start. So understand how to calculate it. The slack time of path 9 is 0 is not yet calculated. I have to calculate and justify why it is called as critical path. Okay, so I will calculate. In this table only I will calculate. So now we will calculate the earliest start. See, go to the diagram. See, T1 and T2. These two are not having any one predecessor. These two are my starting points. So what will be the earliest start parameter result? 0. If you do not have any predecessor path, then your earliest start time is 0. Okay. You don't have a predecessor, so which path's duration you will calculate? Nothing, so 0. Next, T3 and T4 both are having only one path as the predecessor, that is the T1. Both T3 and T4 both are having only one predecessor, that is T1, right? So what is the duration of T1? 4. That means for T3 and T4, my earliest start time is 4. Okay, only one node as predecessor, so that node's value only we will write. Next one, T5. T5 is having only one node as its predecessor, that is T2. T2 to T5, only one node. That means the duration of T2, that is 4. Okay, next, T6. Now, how to reach to T6? There is only one path, T2 and T5. I have to reach to T6 by only one path, that is T2, T5, then T6, right? So what is the earliest start? T2's duration plus T5's duration, so 4 plus 3 equals to 7. No need to write 4 plus 3 equals to 7. I have written because you are doing it more or less for the first time, so you will understand. Next, T7. Now you understand. To reach to T7, I have many paths. Path number 1 via T3, path number 2 via T4, path number 3 via T6. 3 paths. To reach to T7, I have 3 paths, T3, T4 and T6. If I go via T3, what is the duration? 4 plus 2, 6. If I go via T4, what is the duration? 4 plus 4, 8. If I go via T6, what is the duration? 4 plus 3, 7 plus 2, 9. So which one is the maximum duration? That is my earliest start. So which one is the maximum duration? 9. That means T2, T5, T6. Okay. So to reach to T7, I can go via T3 where the path duration is 6. I can go via T4 where the path duration is 8. I can go via T6 where my path duration is 9. Understood? So which one is my earliest start? The maximum time of all the predecessor path. That means 9, 6, 8 and 9. Which one is maximum? 9. So for T7, my path is 9. Okay, I'm not writing the breakup anymore because once I have written and here I am showing you. Similar for T9, T8 and T9. To reach to T8, I can follow via this path, that is via T3, via T4 and via T6. So which one is the maximum? T6 is taking 9, T4 is taking 8 and T3 is taking 6. So which one is maximum? T9, right? Similar for T9. How can I reach to T9? Via T3, via T4, via T6, any of the three paths. So which one is taking the maximum time? The T6 path, that is 9. So both for T8 and T9, my duration of ES is, okay. Next, T10. How to reach to T10? How to reach to T10? There is only one path, that is T2, T5, T6, T10. This path. How to reach to T10? How to reach to T10? There is only one path, T2, T5, T6, T10. Right? So what is the duration? 4 plus 3, 7 plus 2, 9. So to reach to T10, I also have to go via duration 9. Okay. Next, to reach to T11, now see again a problem. To reach to T11, I can go via multiple paths. To reach to T11, I can go via multiple paths. So I can either go via T3, T4, T3. T3 can again be divided into T7, T8, T9. If I go via T4, then also I can go via T7, T8, T9. If I go via T6, then also I can go via T7, T8 and T9, and then only I can reach to T11, right? So if I go via T3, T7, then 4 plus 2, 6 plus 8, that is 14. I am going via T3. If I go via T3 and I take the path of T8, then 18. If I go via T3 and I take the path of T9, then 24. Done. To reach to T11. Now if I take T4, please explain T10. T10, I can reach T10 only via this one path, T2, T5, T6 and T9. There is no other path available. So what is the duration? 4 plus 3, 7 plus 2, 9. So to reach to T10, my earliest start will be 9. Okay. Now, to reach to T11, if I take the path of T4, T3 I have written. Now I am taking the path of T4. Via T4, if I go via T7, then 4 plus 4, 8, 8 plus 8, 16. So 16. Next, if I go via T8, then 20. If I go via T9, then 26. Okay. Next, if I go via T2, T5, T6, and then T7, then also I can reach to T11. Means if I go like this, then also I can reach to T11, right? So I am taking that path for calculation. So T2, T5, T6 means 4 plus 3, 7 plus 2, 9. 9 plus 8. 9 plus 8. That means 17. Next, if I take this one, T8, then 21. And if I take this one, then 27. So if I take the path of T2, T5, T6 and then I go via T7, then I will consume 17 duration. If I go via T8, then 21 duration. If I go via T9, then 27 duration. So I have calculated all the possible paths to reach to T11, right? Now, which is the maximum duration taken to reach to T11? All the numbers are written here. 14, 16, 18, 20, 24, 26 and 17, 21, 27. So which one is maximum? 27, right? So the earliest start of T11 is 27. Okay? Done? Next, I have to reach to T12. I have to reach to T12. Now understand, to reach to T12, you have to reach to T11 either or T10 either, because these two are merging to T12. So to reach to T11, I have already calculated all the paths, and which one is maximum? 27. So 27 plus 8, that is 35. This can be the maximum path, maximum duration if I go via T11, right? Everyone, you don't have to calculate anymore. Why? Every time you have to calculate from T1, right? But here, as I have right now calculated the maximum path for T11, I am not again calculating for all. So what I am considering, the maximum path of T11 is 27. So 27 plus the value of T11, that is 8. So 35 if I go via 11. If I go via 10, what is the value? 4 plus 3 plus 2 plus 10. Right? 4, 3, 7, 8, 9, so 19. So one path is taking 19 and one path is taking 35. So what is my ES? ES will be 35. So calculation of ES is understood by everyone. Did you understand the calculation of ES? What is the calculation of ES? Did you understand? What is the calculation of ES? Did you understand? Yes or no? Okay. So next, what is EF? EF is ES plus your duration. What is the duration? The one that is written on the note. Okay, what is the duration? The duration is the one that is written on the note. So T1, so let me just write. EF is equals to ES plus duration. Okay. ES plus your duration. Fine. So how to calculate that? ES you have already found and durations are written on the node. So that is how you will calculate. So EF for your T4 is 0 plus 4, 0 plus 4. T3 is 4 plus 2. T4 is 4 plus 4. T5, T6, T7, T8, T9, T10, T11, and T12. Okay, so ES you have already calculated, that plus your duration is your EF. So I have just written that. Okay, there is nothing much to understand. Is it clear? EF is clear to everyone? EF is clear to everyone. Durations that are written on the note, you just have to do it a plus with your ES calculated right now. Is it okay? বুঝতে পারছো? Are you understanding? Okay. Next one, confusing one, that is LS. LS, latest start. Very, very confusing. Understand? LS is the one which has to calculate it via MT minus. Formula is this: highest time to finish. So for one node, if I want to calculate the LS parameter, I will be doing a subtraction between MT to the highest time consuming path. The highest time consuming path from that node to the end node. So ES, for calculating ES, we were talking about the previous. We were talking about the previous predecessor maximum duration. Now for the LS, I have to calculate the duration from that node to the last node and do it as a subtraction of the MT that is already calculated as 37. Okay, now I will do it, then you will understand. The last EF is 37 or 47. Last EF T2 has a duration of 2. So what was the earliest start time? It was 35. So 35 plus 2, it is 37, not 47. Okay. Yes, okay. So now the LS means for T1 it is 37, that is my MT, minus the time taken from the T1 highest to reach to the end. Right? Now see, T1, this particular node, if I start with T1, what is the highest time taken to reach to the end node, including the end node? So here my end node has a duration of 2, right? So if I start from T1, if I go via T3, then my highest node will be achieved by T9. If I go via T4, my highest node achieved will be via T9. So if I go via T1, T4, then T9, then T11, then T12. T1, T4, that is 4 plus 4 plus 18 plus 8 plus 2. Right? So this is my highest node from start to the end. So 4 plus 4, 8, 8 plus 8, 16, 16 plus 2, 18, 18 plus 18 is 36. Did you understand? If I start from T1, I can go either via T3 or I can go via T4. Now, which one is having higher duration, T3 or T4? T4, so you have to be a bit logical. When you want to solve it fast, you have to be a bit logical. So if I go via T3 and if I go via T4, which one will have higher duration? Obviously, if I go via T4, right? Now, if I go via T4, I have 3 ways to go: T7, T8, and T9. Which one is having the highest duration? T9, that is 18, right? T7, T8, and T9. Which one is having the highest duration? T9, right? So T4, then T9, then T11, then T12. So that is what I have calculated. The time is 36, right? The time is 36. So 37 minus 36 equals to 1. Okay. Next one, if I go via T2, what is my highest time? If I go via T2, then T5, then T6, this is a common path, I cannot change. So after T6, I can either go via T10 or I can go via any one of T7, T8, T9, right? So 4 nodes are available. After T6, I have 4 nodes available, T7, T8, and T9, and T10, right? So which one among these 4 is consuming the highest duration? T9, that is 18. So if I take the path T2, T5, T6, T9, T11, T12, what is my calculation? 4 plus 3, 7 plus 2, 9, 9 plus 18, 27 plus 8, 27 plus 8 plus 2, right? So what is the value? The value will be 37. Okay. So if I start via T2, my highest duration to reach to the end will be after T6. I have to take the decision that whether I will be taking that T7, T8, T9, T10. These 4 nodes are available. So which one is having the highest duration? T9. So if I go via T9, then I can achieve my highest duration, that is 18. So after T9, I will be having my 11 and 12. So that is 37. Okay. Next one, T3. What is the highest? If I start from T3, then what is my highest path? After T3, which path I will take to do the highest? T9. So T3, then T9. Now see, when I calculate it for T3, I will not consider T1 because T1 is predecessor. And to calculate LS, I have to calculate the after ones, the successors. Okay. So from T3, I will be calculating via T9. So T3 is 2. 2 plus 18, that is 20. 20 plus 8, 28 plus 2, 30. Right? So 37 minus 30. Okay. Next, T4. Similar for T4 also. If I go via T4, what is the highest path that I will take? Highest path will be either T7, T8 or T9. So which one is highest? T9. So I will go via T9. So T4's 4 plus T9's 18 plus T11's 8 plus T12's 2. Right? So 4 plus 18 plus 8 plus 2. Right? So 37 minus 32. That is 5. Okay. Now you go via T5. If you start from T5, you have to go for T6. Then after T6, you have to go via T9 only to complete your task. See, T9 is the highest. Among T7, T8, T9 and T10, all of them are successors of T6. But which one is highest duration? T9. Right? So if I start from T6, T5, then 3 plus 2 plus 18 plus 8 plus 2. 3 plus 2, 5 plus 8 plus 2 is 10. So 15 plus 18. So 15 plus 18 is 33. Okay. Next, T6. T6 is taking the path of T9, obviously T6 will take the path. If T5 has taken the path of T9, then T6 will also take the path of T9 to have the highest duration. So T6 at 2 plus 18, that is 20, plus 8 plus 2, that is 30. Okay. Then you go via T7. Now if you go via T7, see, from T7, there is only one path to finish, that is T11, T12. From T7, there are no multiple paths to get finished. From T7, there is only one path, that is T7, T11, T12, this path. Right? There is no other path because T7 is not going to anyone else. So 8 plus 8, 16 plus 2, 18. Okay. Next, if you go via T8, similarly only one path available, T8, T11, T12. So 12 plus 8, 20 plus 2, 22. Okay. T9, only one path available, that is T9, T11, T12. T9, T11, T12. That is 18 plus 2, 20 plus 8, 28. Okay, only one path available, that is T9, T11, T12. 28. Okay. Next, T10. Now from T10, only one path available to reach the end, that is directly T12. So 10 plus 2, the duration of T10 plus duration of T12, that is 12. Okay. 5 to 25. Okay. T11 is T11 and T12. If I start from T11, only one path to finish, that is T11 to T12. Sorry, T11 to T12, that is 8 plus 2 means 10. Okay. Next, only T12 means this is the last node, so the duration is only subtracted. Okay, so this is your calculation of LS. Calculation of LS. Is it clear to everyone? Those who are attending the class, is it clear to everyone? Calculation of LS. Calculation of LS is clear. The person who is asking for attendance, please give the attendance at the last again. Okay. এখন আর attendance দিতে হবে না. Right now, no need to give any attendance. Give it at the last. LS is clear. LS টা বুঝতে পেরেছো? How to calculate LS? When there are multiple paths, there is a decision to take the LS. That is the maximum path to reach to the end. And what about the single path? The single path to reach to the end, if it is possible, then only that path. Okay. Is it clear? Okay. Okay. Next one, that is LS. So once LS is clear, nothing much in LS. So just let me write it a bit on the right hand side. Okay. So LF and ST. So what is LF? How to calculate LF? Easy. Okay. LS plus duration. So LS right now you have calculated. So that plus duration. So 1 plus 4, that is 5. 0 plus 4, 9. 9, 7, 9, 19, 27, 27. P9 is 18. So 27. 25 plus 10, 35. 27 plus 8, 35. That is 37. Okay. So calculation of LF is done. It is easy, nothing much to calculate. Okay, LF. Fine. Next, ST, the most important parameter for which we are doing all these things, right? So how to calculate ST? ST can be calculated in two ways. One is, the most authentic way is LF minus EF. You can also calculate it as LS minus ES. So we will follow this one. LF minus EF. LF minus EF. So this one, 5 minus 4 equals to 1. 4 minus 4 equals to 0. 9 minus 6 equals to 3. 9 minus 8 equals to 1. 7 minus 7 equals to 0. 9 minus 9 equals to 0. 27 minus 17 equals to 10. 27 minus 21 equals to 6. 27 minus 27 equals to 0. 35 minus 19 equals to 16. 35 minus 35 equals to 0. 37 minus 37 equals to 0. Okay. Calculation of ST. Nothing difficult to understand. Once you have calculated LF and EF, you can calculate this ST as well. Okay. Now, for those for those STs which are 0, we will just mark these. Okay. Next, we will write this T2, T5, T6. ST equals to 0 path. T2 dash T5 dash T6 dash T9, 11, 12. Okay, so this is my ST equals to 0 path, right? Now you see your ST equals to, this is your, which one was your critical path based on your duration? This one, T2, T5, T6, T11, T12. Are they matching? I have calculated on duration directly. I have calculated on the timing parameters. And you see both are same. So this one is your critical path. Okay. Is it clear? Is the problem clear? This is your table. From the table, I have taken ST equals to 0, those nodes I have joined, and I have got the same path which I have got previously as my critical path based on the duration, right? So you can see both are same. So is it clear? The total problem is clear. Now question can be asked from any part, that is how to calculate ES, how to calculate LS, what is EF, LF, ST, MT, anything, what is critical path, how to justify. Now this is your justification. Whenever your slack time is 0, if you connect those paths, that will always consume the maximum duration. Okay. T12 is chosen. T12's ST is also 0. You see, whenever my STs are 0, those nodes I have encircled and I have just written, joined those paths to get my critical path. T12's ST is 0. So T12 is selected. Is it clear? The total problem is clear that we were doing up to now? বুঝতে পেরেছো তো সবাই? You have understood? Without table, you can directly calculate the critical path, but you cannot justify. You require this table to do the justification. Obviously, for T1, you can calculate all parameters. For T2, you can calculate all parameters. Without table, you can do it like that. But anyhow, you have to calculate the ST for everyone. Understood? Fine. Now for in case of project management, today we will be doing only this much. Okay, we have learned what is activity network. There is activity on the node, how to draw this. I have told you how to draw this. Next is what are the timing parameters, what is schedule slippage. Fine. Next, about the predecessors and successors on the graph, I have told you what is immediate predecessor, just the immediate node or nodes, which when completed, then only the next one can begin. Okay. Next one is how to draw this diagram based on a task, a set of tasks given. Next, how to calculate all the parameters, how to calculate the maximum duration, that is the MT. Based on these, how to calculate the ST equals to 0, and that is your critical path. Okay. I hope this is okay to everyone. Fine. Now we will take a 10 minutes of break, and then we will start with the database management system, the transactions. Okay. So just a 10 minutes of break. We will just meet at 11:30, and then we will be doing the transactions, that is the database management system. So for software engineering, this is it for today. If I do go much beyond this, then I think it will be a bit hectic for you. Okay, so we will. What is the real life usage? Real life usage is identifying the critical path, or else your product delivery will be delayed. Schedule slippage will happen. That is the real life scenario. Okay, so we are just taking a 10 minutes of break. You do not leave the session. Okay, if you leave, then your attendance will be again hampered. So do not leave the session, but we will just meet after 10 minutes. Okay, right after 10 minutes.
Recording stopped. Recording in progress.
Okay, so now let us start with the transaction part of the TBMS. Now, in a transaction, what exactly do we have is when you do a bank transaction, like suppose depositing money, withdrawing money, they are not sole transactions of your DBMs. Any process, any process means, if you think of what is a process, then a set of instructions that you write and store in your local disk or in cloud anywhere, it is named as a program. When you start executing, be it a software, be it a normal program, when you start executing, it becomes a process. So process is nothing but a set of logical instructions together that is working, that is a process. And something that is not working but can work when initiated is a program. Any process, a set of instructions together is named as a transaction. Okay. Now in that we have all the process of your parallel processing, that is fetch, decode, execute, store, show output, these things. Now, no need to go into that much detail. So if anyone asks what is a transaction is nothing but a set of logical instructions which is doing a particular single work, but the steps of that work is being divided into sections. Okay, that is your transaction. So if I say a very basic transaction that you do every day, you are withdrawing money from your ATM. Or suppose you are paying something via your UPI, PhonePe, GPay, Paytm, anything. So what happens? Sometimes the money is deducted and the money is just getting added to someone else, or the payment is done successfully. But in some cases, there is a bit of problem. That is, suppose money is getting deducted from your account, but it is not getting added from in anyone else's account. So what is the solution then? Logically, by transaction, by the definition of transaction, either it will be fully done or it will be not done. There is no partial commitment. So here we understand the new term, that is commit. What is commit? See, there are two parts of your memory device. One is the cache and one is the final memory device, that is your RAM, right? Again, I'm not talking about ROM because RAM and ROM, I hope you understand the difference. If you power off the, means if there is a power off, then RAM will lose all its data, right? But ROMs, in case of ROMs, they are permanent type where we store the operating system, the BIOS, these things, which are not regularly changed. So you can ask that ROM, the data in ROM can never be changed. It can be changed. There are ways by which we can force change the data, force alter the data in ROM, but not very frequent in occasion like RAM. So when you do write operation, the data is updated in the cache. But when you do commit operation, the data is getting updated in the primary storage. This is the main difference. So when suppose you are deducting some money from your account and at the same time your father is adding some money to your account, will both work? Yes, both will simultaneously work, but one after the other. So once your money is deducted, the balance will be committed. Then will that data of your father, that money of your father will get added. Okay, the next commit will happen. So this is the very basic of transaction. So concurrent transactions are possible, but that must be going through a schedule. So we will understand what is a schedule. So that will be going under a schedule, right? So what are your content? What is a transaction? What is the ACID property? The states, the concurrency, then the serializability to attain the concurrency, and then the locking protocol. Okay, so locking we will not do today, but before the locking, whatever we have, we will try to finish that today. So this is an example where if some failure occurs, what will happen? That is your question mark. See here, A is trying to transfer some money to B, rupees 10 to B, right? So first, what will happen? This is one logical statement or one logical problem statement. That is, A has to transfer some money to B, but there are some steps. First, I have to find out whether A has got the balance to transfer money or not. Then the money will be deducted from A. Then A will be updated. Then B's current account balance will be read. Then that will be added with the money deducted from A, and then B will be updated, right? So this is your total transaction. See, read A, then A colon equals to means temporary change. Write A means cash is updated, then read B, B colon equals to B plus 10, then write B. Okay. Now this is a set of, this is one particular transaction, suppose T1. Now what if this point where the failure is occurring, B equals to B plus 10, after that the failure is occurring. That means B is not updated in your cache, right? B is not updated in your cache. So what will happen? Either B will be updated at some later time, but will be updated, or the deduction that was done from A will be added back. The deduction that was done from A will be added back, right? So this is your transaction. Now, how I can say that these will happen? Because transactions will be following some properties. The acid property, transactions will follow the properties. So what is acid property? Acid is the initials taken. A stands for atomicity, C stands for consistency, I stands for isolation, and D stands for durability. What is atomicity property? Atomicity property means at a time only one instruction within the transaction will work. That instruction will be fully done or that will be not done. There is no partial done. That is atomicity property. Okay. So atomicity states that either all operations of the transactions are properly reflected on the database or none are. So each instruction has to be done fully or it will be not done. That is atomicity. Next one, consistency. What is consistency property? Consistency means if A is deducted, B has to be added. There should not be any gap. That is consistency. Consistent. If I say a student is consistent, that means what? That person regularly attends the class, that person has got the class lecture notes, that person has secured good marks in the exam. So that person is consistent, doing everything on time, right? So what is consistency then? That means if one portion of a transaction is being done, then other portion of the transaction has to be completed, or else the previous one has to be rolled back. Okay, this is consistency. Next one is isolation. Isolation means there is a single account, the account holder is you. You are debiting money when your father is trying to credit you money. Two transactions are trying to go on a single database, single table rather you can say. So what is isolation? You do not know that at the same time your father is trying to deposit and father does not know that you are trying to deduct some money. Every transaction is being performed in isolation. Okay? Every transaction is performed in isolation. One does not know that other is happening. That is isolation. And last one, that is durability. What is durability? if there is any failure, hardware or software failure, then the changes that are made in your database must persist, means they will not be lost. That is your durability. Okay, that is your durability. So what is durability? When there is any problem with the database, a software crashes, the hardware fails, anything, at that point of time, there must not be any data loss. That is named as the durability criteria of your database. Durability. Okay. So acid property, very, very important, very commonly asked question for a transaction. What is acid property? Acid property is atomicity, consistency, isolation, and durability. Right? So what do you mean by atomicity? All are done or no one is done. Each instruction of your transaction must be done. What is consistency? Any changes that are made, they must be reflected in all the accounts or all the tables involved. Next one, isolation. If more than one transaction is happening, then one must not be aware of the other. They should be performing in isolation. And durability means if there is any problem, then the changes that are made, those changes must persist in the database. That is durability. Okay, this is acid property that all of your transactions in a database must follow. Okay, all of the transactions of your database must follow. Next, what are the possible states that a transaction undergoes? Transaction undergoes more or less 5 to 6 stages. Once the transaction is initiated, it is in the active state. Some read-write operations are done. Please understand, in a transaction, only two operations mostly we will work with. One is read and write, and the other one later we will work with commit and abort. Okay. For successful completion, commit, and for rolling back, abort. So active state, from their read-write operation, it is going to partially committed state. From the active state or the partially committed state, they can fail and go to a failed state. If it is a failed state, it will go to abort. If it is committed and no problem occurs, then it will go to committed state. And finally, whether it is committed or it is aborted, it will go to the terminated state. That is the last one. Okay. So any transaction can undergo these six types of states. Okay. So what is the difference between partially committed and committed state? This can be a type of questions that will be asked. Okay. Next one, when you understand this, that one transaction, when we are dealing with one transaction, then these things are present. When you are dealing with multiple transactions, that is concurrent transactions, more than one transaction happening once in your database, then concurrent means more than one parallelly happening. So if there is any problem, what will happen? Based on that, we have few problems identified. 4 or 5 types of problems identified. They have specific names. So first we will study the problems and then we will come to the like how to control concurrency, right? So first problem, we call it as the dirty read problem. Dirty read problem. What is it? Take the example of yourself. In exams, more or less, most of the students are busy in copying from each other. Right? There are many students, most students who are doing the copying, right? Now, identify the problem. Suppose person 1 is copying from person 2. Copying means looking at their copy and writing unknowing of person 2. So, suppose person 2 has finished writing, that person has given a break, and person 1 thinks that I have written enough from person 2, so let me just submit. Anyhow, I will get a 70 to 75% marks, no problem. So let me just submit my copy. Fine. So that person has handed over the copy to the invigilator and left. Means what? That person has committed. Means after you submit hand over your copy to the invigilator and leave the exam hall, you cannot come back and retake it. All of you know that. So after that, that person is standing outside the classroom. Now that person is seeing that person 2 from whom he has copied, that person 2 is making some changes in the answers. Oh my God. That means some of my answers may be wrong that I have written and submitted. This means what? Before the person whom you are taking the assistance, before that person is committing his or her copy, you have committed it in a hurry. This problem can bring some problems in your transactions, right? So this is named as dirty read. You are reading unknowingly from any other transaction, but that transaction may or may not have committed his or her word or instructions, right? So you are doing it wrong. So you may face some consequences. Some of your answers are wrong now. So this is dirty read. Have you understood? Have you understood? See here, T1 is doing read A, write A, but not committing. But T2 is then doing read A, that is reading the value of T1 and then committing. Then your T1 is committing. So if T1 is having a problem in between, what T2 will do? T2 has got already commitment, so it cannot change its value. This problem is named as dirty read. Okay. Next one, unrepeatable read. Unrepeatable read. If there is a common data item between two transactions operating parallelly, then the transaction 1 is reading a value, T2 is also reading the same value. So there is a problem. After that, T1 is changing the value, writing off that value. And then T2 again reads the value, but T2 gets the updated value because T1 has written, so T2 is getting the updated value. Means what? Unrepeatable means the read that has already occurred, this read that has already occurred, this value is now getting updated here, and the updated value is getting read by the T2 second time. So the first time's value, if it was 5, suppose, now it is updated to 7.5. Now the T2 is not getting 5 back, it is getting 7.5. So this is unrepeatable read. The read operation that you have once done, next time when you are going for a read, that read is not giving you the previous value. Okay, you are getting some different values. Okay, this is unrepeatable read. Next one, phantom read. Now, phantom is what? Phantom is a type of superhero that we all come across. Now, your transactions which are concurrently performing, the transactions are always in isolation. I do not know if some other transaction is going on or not. So T1 and T2 both are unaware of the fact that something else is going on or not. Right? So here, if there is a value X which is somehow in the middle deleted by T1, then when T2 tries to read the value, the T2 gets an error that X, this data does not exist. Now that T2 is just shocked that how it is not existing. Right now I have seen that T2 that X was existing because T1 has deleted the value of X. But T2 is in isolation. T2 does not know that what is going on in the schedule, right? Hence, T2 is just in shock that what has happened. This is named as phantom read. You are trying to read a value which you have previously read, but the value is suddenly disappeared from the database, it seems. So we call it as the phantom read. Last one, the lost update problem or the blind write problem. Blind write means you are writing a value without knowing that some other transaction is also there in place, and that transaction also has got to update its value sometime. So that type of write is named as blind write, means write without read. Write without read. That is named as blind write or lost update problem. Okay. So these 4 type of problems you will face when you go through your concurrent transaction. Okay, so no, I was in the middle of a call. Okay, phantom read. Phantom read means if unexpectedly at some point of time, any data item which is shared between more than one transactions is getting deleted. So the other transaction which is also working but in isolation does not know that what exactly is happening. That transaction does not know that what exactly is happening. Why the data item which I have just read right away is not getting access. It is giving me an error that the data item is not deleted because some other transaction which is also accessing it, that transaction has deleted that particular data item. Okay. So this is phantom read. When you have more than one data items present, sorry, more than one transactions concurrently working, then if you delete a data item that is shared between all, then the other transaction will not have the idea that how it is getting deleted. Right now I have accessed it. So this unknowingly being deleted action is being named as phantom read. And what is lost update problem or blind write problem? When a particular transaction like here is writing on a data item without reading, writing a data item without reading, then we call it as the blind write. Okay, you can see here T1 is reading the data item, then updating the data item. T2 is writing the data item, like updating the data item again and committing. That means A is becoming 20 permanently here. Then again, when T1 is trying to access the value of A, then T1 is getting some other value which is not expected. T1 is expecting 11, right? Because T1 has last changed it 11. And T1 is in isolation. So T1 does not know that how 11 is changed. But 11 is committed by T2. T2 has not read that T1 was 11. T2 is having it as 20. Right? So T1 is now getting it as 20, but T1 is supposed to get it as 11. Right? So this is your lost update problem. The update that you have made is just lost. Right? So this is your lost update problem. Clear? All of them? Dirty read, unrepeatable read, phantom read, and lost update problem. Clear to everyone? Please answer whether it is clear or not, whether you have understood it or not. Okay, so when the transactions, more than one transactions are in like concurrency, then any one of these four can happen. Okay, so to avoid all this, we will be going through few of the few of the types of actions that we can take. So first we will learn the serializability. Okay, so I am sharing the next PPT where we will learn the serializability. Okay. Okay, so here you have the content, the concept of transactions, the acid property, the states. Now you come to concurrent execution of transactions. What do you mean by concurrent execution of transaction? Okay, so when you have concurrent, what is the requirement of concurrent execution? The parallel processing. As simple as that, the parallel processing. Now see, When you have parallel processing, you have efficiency, you have more CPU usage, disk usage, these things. So that is why we require the concurrency. But as you have seen, when we go through concurrency, we can face a lot of problems. So for that, we will be discussing some of the concurrency control scheme. So for that, first thing we will understand is what is a schedule. A schedule is the representation of the concurrent transactions through a tabular structure. So this one you can consider it as a serial schedule. What is a serial schedule? If one transaction does all these instructions present, then only the next instruction or the next transaction starts. Then that is a serial schedule. One by one, transactions are working or transactions are performing all its operations. One by one, the transactions are performing all their operations. That is schedule. Okay. So what is a serial schedule? If there is no changeover between transactions. If there is no changeover between transactions, that means first T1 will start, do all its work, then T2 will start and do all its work. So one after the other. This is your serial schedule. So here you can see again T2 is starting, and once T2 is done, then T1 is doing its work. So there may not be any order, but only criteria is there is no changeover. Once T2 is starting or T1 is starting, that person will do all its instructions present in its transaction. Then only the next type of instruction will start. Okay, so in the midway, one will stop and other will start. There is no preemption. There is no preemption. Okay, so this is serial schedule. What is a non-serial schedule? A non-serial schedule is whenever there are changeovers, there are context switching. What is context switching? If there are more than one processes, then when one process is stopped and the other process is getting started, that is the other process is getting some chance to execute. So the other process will be executing for some time, and then that process will again stop and the previous process will get some time to work. This is your non-serial schedule, right? So what is non-serial schedule? Non-serial schedule means whenever there are context switching between processes, when one process is stopping and other process is given some chance to work, then the other process will stop, give the first process some chance to work. Like this, the process handling will go on. Is named as the context switching. And if it happens like this, we call it as a non-serial schedule. We call it as a non-serial schedule. Right? So difference between serial schedule and non-serial schedule. When a schedule is having more than one transactions, but The schedules instructions are working one after the other, then it is serial schedule. If the working is such that one transaction is working, stopping, then giving the other transaction to work, and like this the process goes on, then we call it as the non-serial schedule. Now see, one schedule which is serial, then one after the other is working, but someone which is non-serial, then the consistency problem will arise, that is which one is working after what, or which one is getting committed, which one is not getting committed, so on and so forth. These type of problems will arise. Hence, we always try to go for serial schedules. Any schedule given to us, we will always, our aim will always be there to convert it to a serial schedule. And the process of conversion, we call it as the serializability. If a non-serial schedule is able to be converted into a serial schedule, we call it as the serializability. Okay? Up to this is clear. What is serial schedule, what is non-serial schedule, and what is serializability? If a non-serial schedule is able to be transferred to a serial schedule, then we can guarantee the consistency, because one after the other it is performing. So we will try to go for serial schedules, right? And the process of the conversion, we call it as the serializability. Okay, is it clear? Is it clear to everyone? Okay, so there are two ways by which we can process the serializability. One is conflict serializability, by checking conflict serializability, and one is view serializability. One is view serializability. Okay. So first is, what is conflict serializability? To attain conflict serializability, we will first understand which are the conflicting instructions. Which are the conflicting instructions? See, the first condition is, if two transactions are working on the same variable, same data value, and any one of them at least is a write operation. So there will be two transactions given. First, we will find out whether there is a common data item being accessed or not. If a common data item is accessed, then we will find out whether at least any one of the transaction is write operation or not. If anyone or both are write operation, then we will say that they are conflicting instructions. They are conflicting instructions. And if both are write operation, then whatever be the data items accessed, there will be no problem. They are non-conflicting instructions. They are non-conflicting instructions. Okay. Now, How to perform conflict serializability? If there are non-conflicting instructions between transactions, then the timestamps can be exchanged. The timestamps can be exchanged. Look at this. Look at this slide. See on the left hand side, schedule 3, I have a non-serial schedule. Now in this one, T1 is working on A and B, T2 is also working on A and B. T1 is first reading and writing, T2 is then reading and writing all on A. Then everything is being done on B. Now see, this set, follow the cursor, this set is working on variable A. This set is working on the variable B between two transactions. So different data items, that means these two sets, they are non-conflicting. Conflict, if I have to find conflict, there will be common data item. But here there are mutually exclusive data items. So I can swap them. Swap what? Swap their timelines. So this one will come to this one's timeline, but not in T1, in T2 only. The transaction will remain same, but the timestamp will be different. So these two sets, this set is working on A, this set is working on B. So they are not conflicting. So this will be coming here in parallel and this will be going here in parallel. So the timestamps are exchanged. This will go here. Wait, I will just show you. Just wait for a minute. So here, this one, here, these two are non-conflicting because this one is working on A and this one is working on B, right? So if they are not working on the same variable, they are non-conflicting in nature. So what I will do, I will swap their timestamp. Swapping does not mean this will go in T2 and this will go in T1. No. This will go to this one's timestamp, this one's parallel timestamp, and this will come to this one's parallel timestamp. So see here, this has come here and this has come down. So this is how you can convert a non-conflicting transaction set to a serial schedule, a non-serial schedule with non-conflicting instructions can be converted to a serial schedule. Okay? Is it clear? Is it clear? So when this particular read this particular T1's read B, write B and T2's read A, write A, if these two are non-conflicting instructions, because they are working on different variables, so they must be non-conflicting ones. So if they are non-conflicting, then what we are able to do, we can swap them. What we will swap? We will swap their timelines, but transactions will not swap. And likewise, we will get the schedule 6. Okay, so schedule 3, if you have, suppose this was also write B, read B, write B. So then these two cannot be swapped because write instructions are present and on the same variable, both are on B variable, so they cannot be swapped, right? So if the data items are different, then we can swap. Even if the data items are same and the instructions are only read instructions, then also we can swap. Okay, so this is how we can achieve the conflict serializability. We can achieve the conflict serializability. Now next day we will start with precedence graph. That is, only by checking the conflict serializability it will not work. We have to take some shortcut, and that we will attend towards the precedence graph. Okay, so today I will end it here. Next day we will start from the precedence graph of transaction, and parallelly in the software engineering we will be working either with project management or we can work with the SDLC models. Okay, so today we will end the class here. Those who have missed the attendance, if you have missed, then only give the attendance. If you have not missed, no need to give. Okay, if you have already given, then no need to give. If you have missed the attendance, then please give the attendance. Once again, Shubho Poila Boishak to all of you. Shubho Noboborsho, the happy Bengali New Year first day to all of you. Best wishes to all of you. And we will see you in the next class. Thank you.